Now let us look at the solution to this question, and of course we will start by reading the question together so that I can outline the various important physical quantities in the question which will help you to answer the question. And let's go right ahead. We are told that a car of mass 1200 kg, that is M, of course, let me change the color, decelerates from, this is U, to 20 meters per second, this is V, in a time of 6 seconds. So this is T, 6 seconds. We are asked to calculate the magnitude in newtons, of course, of the decelerating force. The moment we see a question like this, we know we have to use the equation F is equal to ma, because this is basically dynamics. F is equals to ma. F is the resultant force which causes an acceleration A when it acts on an object of mass m. Let's substitute here in terms of symbols. A is V minus U over T. And you can see that all these physical quantities are given. So the M is 1200 kilograms. V is 20 minus 30, and that will give us minus 10. And of course, T is 6. And a manipulation of this substitution gives us minus 2000 newtons. So in order to answer the question, you will say that the decelerating force is 2000 newtons. Where has the negative sign disappeared to? This is what it means. When we use the equation F is equal to ma, F is the force which causes that body to accelerate. So I'm calculating the accelerating force, because A is not a deceleration, it is an acceleration. So when you use the equation F is equals to ma, remember F is the resultant force which causes the object to have an acceleration A, and both of them are in the same direction. But when now a negative sign appears there, you will have to reason out that this force acts in the opposite direction to the direction in which the object is moving, and therefore it is a decelerating force. So the absence of the negative sign here is taken care of by this word here. So when the examiner asks you to calculate the decelerating force, in your calculation, you will encounter a negative sign. But in your answer, you won't say F is equal to minus 2000 newtons. No, you will have now to state your answer so that it is in line with what the examiner wants. And the examiner wants to calculate the decelerating force. And it is the same case with part B. Let's look at part B. In part B, we are asked to calculate the loss in joules of the car's kinetic energy. We know kinetic energy is given by a half mv squared. So I want to start by calculating the gain in kinetic energy, delta E. I have to assume it's a gain, although I know the examiner has asked me to calculate the loss. It will take care of itself. And this is how it takes care of itself. The change in kinetic energy, or the gain in kinetic energy, is equal to the final kinetic energy, which is a half m v squared minus a half m u squared. I can factor out the m so that I remain with v squared, or let me just write it in full so that you don't miss out anything. Of course, remember, even in this part, how did I get minus 10? I did 20 minus 30. That is how I got minus 10. because I skipped that step. I shouldn't have. So here we have a half. Of course, now we have m into bracket v squared minus u squared. I'm making my substitutions to be as complete as possible so that I don't lose you in any way. So this is a half. The mass is 1200 kg. V squared is 20 squared, which will be 400. And u squared is 30 squared, which is of course 900. 400 minus the 900 will give you minus 500. There is that negative sign. When you multiply that by, of course here we've got 600, you're going to get minus 300,000 joules, of course. So the negative sign shows that what I was calling a gain is actually a loss, is actually a decrease in that physical quantity, is actually a decrease in the kinetic energy. So in order to answer this question here, because I've been asked to calculate the loss in kinetic energy, I will just say it is 300,000 joules. And of course, forget about the negative sign. It's just a simple trick that examiners use here. But they are using the common language that we use every day. What is the decelerating force? What is the loss in kinetic energy? All those are terms that we can use in everyday language. But when it comes to this form of calculations, you've really got to know that there is a certain method that is supposed to be followed. And throughout my mechanics course, I've followed this kind of method. It really puts everything together so that when it comes to calculating any change in any physical quantity, you'll find that in my whole course, I always start with the final minus the initial. You will never go wrong when you do that. Even if the final may have a smaller value than the initial, and therefore, there is a tendency for students to swap values around. You see, if you use F is equals to MA and you swap those values around, you'll find that your F will be equal to 2000 newtons. Actually, if you swap these values here so that you say, instead of saying 20 minus 30, you say something like 30 minus 20, so that you avoid that negative sign. If you do that, you will find that you'll get an accelerating force of 2000 newtons. So this object will not be decelerating, it will be accelerating. That is the mistake that you can make. So never swap these values around. And that is one of the big lessons that I want you to learn from this example. In all the other examples or all the other questions I've used in my course, I've stuck to this method. If you find that this question has helped you to answer certain questions that you had in your mind, then I've got great news for you. Just click the link below and it will take you to my course where I have a number of free lectures just to give you a taste of what you're likely to encounter when you enroll in the course. I have about 10 or so free lectures which actually teach you content in Mechanics 1 before you can purchase that course. So just click the link below and go there and see how I tackle various aspects of Mechanics 1.